Factoring, this one is a unique case, and if you're lucky enough to notice that it's something called the difference of squares, you're in really good shape, and it'll save you some time. So I'm going to write down difference of squares, and then we're going to talk about what it means. When I say difference, I mean subtraction, and when I say squares, I mean perfect square numbers. Now, if you look at this one, 36 is a perfect square, x squared is a perfect square, 25 is a perfect square, and we're taking the difference of them. So this is officially the difference of squares. And the difference of squares, which you could write it out as a squared minus b squared. All you're going to do is you're going to put a plus b in one parentheses and a minus b in the other. And what ends up happening is that those middle two terms, when you distribute, are opposite and equal. And so they cancel each other out, leaving us only with a squared and a negative b squared because of this negative sign right here. So let's take a look at 36x squared and negative 25. If I go right to my parentheses, I'm going to put a plus in one and a minus in the other. The square root of 36 is 6. The square root of x squared is x. And the square root of 25 is 5. And I have successfully factored this difference of squares problem. And this works really well with any sort of perfect squares. Maybe I have 16x squared minus 9. If I were to break this down, square root of 16 is 4. Square root of x squared is x. Plus in one, minus in the other. Square root of 9 is 3. It's really straightforward. And so if you ever see one with just two terms and there's a negative sign in the middle, ask yourself, are these both perfect squares? Because if they are, I'm in luck.